Hi everyone. We're going to determine if each pair of events is a mutually exclusive or mutually inclusive, and also determine each probability. So the first thing I'm going to do is look at our first problem. The probability of tossing two numbered cubes is either one shows a 4. So for the first one, we have that it's inclusive because if we toss two number cubes and either one shows a 4. So the first one shows a 4. Then the second one shows a 4. Then we have to subtract 1 over 36. And that gives you 11 over 36. And basically what you're subtracting is, we only need one of them, not both of them. So you're actually you're subtracting the duplicates there. So this one's inclusive. All right, next one. The probability of selecting an ace or a red card from a standard deck of cards. So a probability of selecting an ace is 4 over 52, or means plus, a red card, which is 26 over 52. Now what happens is there's two cards that are red, so we basically counted them twice, like in the previous problem. So we have to subtract those two out. And when you fix this up, you're going to get 7 over 13. So this is mutually inclusive. It's always inclusive if you have to subtract out the duplicates that you already included in these two, because you counted them twice, basically. All right. The probability that a card is drawn from a standard deck, it is red or a face card. So if it's red, there's 26 red cards, and there's 12 face cards, but we have 6 face cards that are red. So we're subtracting out the 6 that we've already counted. All right, and it's easier than trying to figure it out when you're doing these. So you're just adding them up and then subtracting out what are the duplicates. So that's going to be 8 over 13, and this is inclusive. All right. Next one, the probability of picking 5 puppies at which at least 3 are male from a group of 5 male puppies and 4 female puppies. So basically we want the probability of at least 3 males. That means the probability of 3 males or the probability of 4 males or the probability of 5 males. Okay, and this is going to be exclusive because it doesn't depend on the first choice. So the first one, I'm going to do C. We're picking 3 males, and from the 5 puppies, that means we have 4 females, and we're choosing 2 from there. I'm picking 5. These two numbers should add up to 5. Then our total is 9 puppies, and we're choosing 5. Okay, then we add 4 males. So from the 5 puppies, we're choosing 4 males. That means the other one out of the 4 has to be 1. All right, and that's still C, 9, 5. And the 5 males will just be C, 5, 5. You don't have to put the 5, 0, because that just equals 1. So it's going to be C, 9, 5. And what you're going to get is 60 over 126 plus 20 over 126 plus 1 over 126. It should be 126 And this equals 81 over 126, or 9 over 14. Okay, the next one, we have the probability of 2 number cubes being tossed and showing a sum of 6. So we either want the probability of the sum of 9 or the probability of a sum of 6. Okay, this is exclusive because one doesn't depend, we're not going to be counting it twice. So the probability of a sum of 9 is 5 over 36. And the probability of a sum of 6, you can write the sample space down if you want, is 4 over 36, which equals 9 over 36, which equals 1 over 4. Okay, next one. The probability of 6 people selected at random from 7 men, so 6 people, 7 men and 7 women, will have at least 3 women. So at least 3 women will be the probability of 3 women plus the probability of 4 women plus the probability of 5 women plus the probability of 6 women. Okay, so let's write it all out. Probability of 3 women would be, we're choosing 3 women from 7, and then we're choosing also, because we're choosing 6 total, 3 from the men. And that's over C 14, 6. The 4 would be C 7, 4, and then times C 7, 2. So we only have 2 men on that one. And our denominator is always the same. And then for this one, it would be plus C 7, 5 times C 7, 1 over the same denominator. And the last one would be C 7, 6. And we really don't need to put this one. 7, 0, that just equals 1. So you can put it down if you want. So this is C 14, 6. So if I write real small here, I'm going to get 1225 over 3003 plus 735 plus 147 over 3003 plus 7 over 3003. And simplifying that, after you add it up, you get 302 over 429. The next one, we want the probability of at least 4 tails facing up when 6 coins are dropped to the floor. So at least 4 tails would be probability of 4 tails plus the probability of 5 tails plus the probability of 6 tails. So I'm going to use my binomial theorem, that's C 6, 4, and I can just do 1/2 to the 6th plus C 6, 5, and that's going to be 1/2 to the 6th. This is basically your denominator right there, plus C 6, 6 to the 1/2 to the 6th. So basically 2 to the 6th is 64, so you're going to get 15 over 64 plus 6 over 64 plus 1 over 64, and that's going to give you 22 over 64, which reduces to 11 over 32. Okay. the probability that 2 cards drawn from a standard deck will be aces or both be black. So this is inclusive. So for them both to be aces, that's going to be 4 out of 52 times 3 out of 51. And then for them both to be black, we have 26 out of 52 times 25 out of 51. And then we have to subtract the duplicates because we have 2 aces that are black. So that's going to be 2 out of 52 times 1 out of 51. And you simplify that, you're going to get 660 over 2652, which is 55 over 221. Okay, and the last one we have is the same thing. We have 6 rock and 5 rap CDs. We want at least 2 that are rock from a randomly selected. So at least 2 rock is the probability of 2 rock plus the probability of 3 rock. Okay, this is exclusive because we don't have to subtract out duplicates. So that's going to be C 6, 2 times C 5, 1. Because if you have 2 rock, then you have to have 1 wrap. And our total CDs is 11, and we're choosing 3. And then or, we're going to have choose 3 rock, and that means no wrap, which we don't really have to write that because that just equals 1. And then this would be, we still have 11 over 3, or 11, 3. So that's going to be 75 over 165 plus 20 over 165, which equals 95 over 165, or 19 over 33 when you reduce it. Okay, that's all. Thank you. Have a nice day. Bye-bye.